In this class, two topics which were not covered till now: Fourier and Laplace transform. So I will just cover those two topics in today's class, solve some questions, and then we will end this session. So to start with, what is first of all what is Fourier transform? So just little introduction. So why do we need Fourier transform? So suppose you have any time series or any signal, suppose f of t. Suppose it is a function of time. It can be a function of anything, like I'm taking time. So, and if you just plot this function, suppose you get something like some kind of signal noise, some kind of you're getting, and you want to know that what is the dominant time period or periodicity associated with this time series, with this signal, with f of t. There is, you can see there is some high frequency variation, then there is some low frequency variation also there. So what is the dominant time period associated with this ft? So in order to find that, what we do is that we convert this signal from time domain to frequency domain, from time domain to frequency domain, say f of omega, and then just we plot the power spectrum of those. Like on the y-axis, x-axis you have frequency, and then on the y-axis you have some power. Okay, and when you plot this, you get something like, suppose something like this. The corresponding to two frequencies, you get the maximum amount of area is like centered around these two frequencies. Then you can say that, okay, with this signal f of t, the dominant periodicity is corresponding to these two frequencies. That is f1, that is suppose t1 like 1 upon f1, and t2 1 upon f2. Like these are the dominant time period associated with this frequency. Just to give some example, for example, let us take example that you have the amount of sunlight which you receive on Earth. So you have one period, dominant time period is 24 hours, because every 24 hours you have day and night. So, and another periodicity with this day, with this sunlight is season. In summer season, we receive more sunlight than in the winter season. So that is another 3 months is another time scale associated with the amount of sunlight which you receive. So this is roughly a vague idea I want to give, that what is the periodicity associated with any signal. So Fourier transform is just used to understand those periodicity associated with any time signal, not only anything. You can have any kind of time series, and then you can just do the Fourier transform. So mathematically, suppose you have any signal and you want to, the Fourier transform, which is represented in this way, of that signal is just integral of that function f of t e to the power minus I omega t dt, where omega is your angular frequency, is 2 pi. So this is how we just represent the Fourier transform of any continuous signal f of t. And similarly, if you have some discrete signal, then you can just replace this summation with this integral sign with summation. But in our syllabus, we are not dealing with this discrete type signal.
So one question here.
Yes, yes.
When you are representing Fourier transform as this integral form, you are not writing the 1 by root 2 pi part. So are you including 1 by 2 pi in inverse transform then?
That is just a constant, normalization constant. So it's up to you. You can just uh, take that into consideration. I'm not considering here. Maybe
Okay.
inverse, when I do inverse Fourier transform there, I will just take that.
Okay, so that normalization means it is same like that orthonormal condition in case of Fourier series. It is coming from the same reason here, the normalization constant.
When you do the, yeah, you're right. It's come from there only. It's just a constant, doesn't make any difference to the physics of the question. Okay.
Okay.
Okay, so yeah, so this is how we mathematically represent the Fourier transform of any function f of t. And similarly, if we want to do the inverse, we can just inverse of any, suppose we have some, so so you can just write this e to the power I omega t d omega. So this is the two mathematical representation. Now let's move towards the question. So the first question which I want to discuss with you is on question number 64 gate 2015 paper. So the question they have gave is that they have given some Heaviside function which is defined as this. So this is some, for t greater than 0 it is some constant 1, and then for t minus 1 it is minus 1 for t less than 0. So there is a discontinuity at 0. So they have shown that the Fourier transform of this function is already given in the question. So the Fourier transform of this, sorry, the Fourier transform of this function h of t they've given is minus 2I by omega. Now they have asked you what is the Fourier transform of a function which is displaced by amount half. So this kind of question, because it can be solved by using shifting property. So simple 3-4 lines derivations. For example, if the Fourier transform of any function f of t we already know is given by minus infinity to infinity f of t e to the power minus I omega t dt. And if we just displace or translate this signal or shift the signal by amount constant terms, some a, then we can just write it as dt. Now you can just replace t minus a by u. So dt will be du. So what you'll get is minus infinity to infinity f of u exponential minus I omega. You'll replace t with a plus u. So minus e to the minus I omega du. Okay. Or you can just write it as e to the power minus I omega a times minus infinity plus infinity f of u e to the power minus I omega u d. Now this term is nothing but already given in the question. It is the Fourier transform of a function f of u. So we just apply this property. So in our question they have asked what is the Fourier transform of, we have been asked this, t plus half minus h of t minus half. So we know that since here if you just compare with this equation, then here a is with just exponential minus omega a term will come in as a constant. So here your a is minus 1 by 2, and here your a is 1 by 2. So you'll just simply write e to the power minus I omega by 2, and since your a is minus, so it will be plus, and times the, this is nothing but the already given the question, minus 2I by omega times minus 2I by omega. And similarly here you can write this minus I omega by 2 minus 2I by omega. I can just take minus 2I by omega common, or this 2, and then you will just get simply e to the power minus I omega by 2 minus e to the power I omega by 2. Now you just take 2I to the denominator, so you will left with, and e to the power I omega by 2 minus e to the power minus I omega by 2. Since when I will come in denominator, it will become minus I, so I've taken care of this sign by replacing this like this with this. So this when you solve is nothing but, sorry, one mistake. There will be 2 in the numerator because I've taken I just down. So yeah, so let me correct it. I've just taken I in denominator, 2 is already there, so 2 by omega will become here. This is okay. Now this you can just easily write as this is nothing but sine of omega by 2, because we know that sine of theta is exponential I theta minus exponential minus I theta upon 2i. So just using this we can just write this as this, or sine of omega by 2 upon omega by 2. So this is finally what we got is the Fourier transform of this question. So A option is the correct option for this question. Is it clear, this one?
Yes.
Okay. So now next question is another question where they have given you that Fourier transform of some delta function. So Fourier transform of some delta function they've already given in the question. It is, or we can also calculate it is simple. You know that x dx. So we know by the property of delta function this will be nothing but f of a. So your function is exponential, so you just replace x with a. Just using this property, del x minus a fx dx is nothing but f of a. We will just get exponential minus I omega a, and you can write this as 2 pi a nu. So this is what they have given in the question. So given this, what will be the inverse Fourier inverse of this cos of 2 pi ab? So as soon as you see that there is the exponential term, and you can write cos also in the exponential form, so you just have to write cos in the exponential form. E to the power I 2 pi a nu plus e to the power minus I 2 pi a nu upon 2. Or you have to calculate Fourier inverse of exponential 2 pi a nu, okay, plus inverse of minus of 2 pi I a nu. So this you have to calculate. Now using equation 1 you can find it, because this is equation 2. So from equation 1 you can just write as Fourier inverse of exponential minus 2 pi I a nu is nothing but del of x minus a. Just taking this side. So similarly now we'll use this is 3 back in 2. So we know that inverse of the exponential minus 2 pi I a nu is nothing but delta. So we just use in these two equations, and then we will get half sign will come, and here your here it is minus, so it will be del of x plus a plus of Fourier inverse of exponential. This is what? This is nothing but del of x minus a. So just we've used this equation 3 and equation 2. Here your positive sign, so your a is like, so you just replace this with positive a with minus a, so it will become positive, so it will become del of x plus a. So that you can just, and hence and Fourier inverse of exponential minus 2 pi a nu is del of x minus a. So there is two terms, del of x plus a and del of x minus a. So in this way your answer is this, and which is I think D option, this one. So simply it's just a simple question, you just have to use this property of inverse. So this is clear, right?
Yes.
Okay. Now again question.
Yes.
Hello. Okay. So okay, next question, there was another question, it was asked in, long back 2004. So they have given some Fourier transform of a function of fx is defined as, so f of k is nothing but minus infinity to infinity f of x exponential. So they have defined Fourier transform this way. Then what is the Fourier transform of this function exponential minus x square? So you just put this into this equation, exponential minus x square plus ikx dx, because exponential will just add, their product of the exponential just we can write in this form. And in the question they have given this, in GATE exam generally they give when they see that there is some complex long integral, so they just give in the hint. So in this question they are given in the hint that this form of integral is given by root pi by a exponential b square upon 4a. So using this, in this question your a is 1 and your b is ik. So your answer will become root pi a is 1, exponential b square is nothing but ik whole square, which is minus k square upon 4. So your B option, but will be correct. But let us, I will just, we can just solve this equation. Even if we don't, even if it's not given in the exam, we can just easily find this equation. So I will just do that. So your ax square minus bx can be written as ax square minus bx plus b square by, I'm just trying to convert it into perfect square. So just taking the half of this coefficient of x and squaring it and then adding it and subtracting it. So half of it b by 2, so b square by 4a. So and just like in this form I'm converting it first and then I'm just adding and subtracting it. Now this you can further write it as under root ax, x is outside the under root, minus b upon 2 root a whole square minus b square upon 4a. You just open this, you will just get back this a square minus bx. Okay, so we can write this ax square minus bx as like this, and now we'll just put this back into this question. For example, we are solving this integral e minus ax square plus bx. So e to the power minus ax square minus bx dx, we can just substitute it as minus this, we can substitute minus b upon and second term is exponential minus sign minus minus plus, so there is minus here also, so minus minus plus, so b square upon 4a. So this is a constant term, so it will come outside the integral and you're left with this. Now you just do the substitution method. You just substitute the quantity in the bracket with some another variable t. So your dx will be dt upon root a. So your equation will become exponential b square upon 4a minus infinity to plus infinity, exponential minus of t, and dx will be dt upon, sorry, there will be square term because we are substituting this as t. So dt upon root a I'm taking outside. Now again you put t square is equal to u. So your 2t dt will become du. So dt will become du upon 2 times t or du upon 2 times under root of u. Put this back in this equation, so you will get exponential d square upon 4a upon root a minus infinity to infinity e to the power minus u, and dt is nothing but du upon 2 will come outside and under root u in the denominator, so I can just write it as u to the power minus 1 by 2. Now there is a property of gamma function that this type of integral, if we have this kind of integral e to the power minus x, x to the power n minus 1 dx, so you can just write it as gamma of n. So this function is also similar to that. So we have e b square upon 4a upon root a 2. We can just I can just replace it with, since it's even function, so we can just replace, change the limit 0 to infinity and multiply 2. And now this will become what? U to the power minus 1 by 2 e to the power minus u du. So if we just compare this, suppose this equation A with equation B, then your n minus 1 is what? Minus 1 by 2. Therefore your n is 1 by 2. Therefore this will become, hello?
Yes, gamma half should come as
Yes,
root pi.
root pi. So it will become root pi. These two to cancel. So there is one root in the, so you will get what? Root pi by a exponential b square upon 4a. So this is what you will finally get. And this is what is given. So even if they do not given the hint, you can just calculate the answer. And based on this integral, you can just solve this question, and the answer is what we've already seen. Since here your a is -1 and b is ik, so just put in this and then you'll get the answer. So root pi exponential minus k square by 4. So B is the correct option for this question. Clear to both of you?
Yes.
Okay.
Yes, sir.
Okay. In the first session, I solved this question. I like this integral. I solved geometrically, like in polar coordinates. Also, you can just try. You can just go to that PPT. Like here's gamma function approach is much easier to solve, but you can just use some polar coordinates also and solve this integral. Then also you'll get the same. You can just go to that slides if you want to see. Like there are different ways through which you can solve any integral. Okay. Okay. Now another question which I found is like this kind of question are important because they are little tricky, but they do not require long solving like 1-2 page. They are just 3-4 lines, and this type of questions comes in like different exams. So they have given that Fourier transform some function is this. We already know. Then what is the Fourier transform of f of the Fourier transform? So we can just write this as f square. You can just write it as in this form, f of maybe something like this. So Fourier transform, the Fourier transform of f of x. We can write this, okay? And let us have that this Fourier transform of f of x, which we write here. See here they have given this constant term. So fx exponential minus ikx dx. Let us say it is given by f of omega. So this is equation 2, this is 1. Okay, so from equation 2 you can write f of x is nothing but 1 by root 2 pi f of omega, which is just, you all know that this is nothing great. This is just what we know. Now we'll just use equation 2, equation 1, and equation 1 we can write this, we substitute this with this f of omega. And this is nothing but 1 by Fourier transform of any function is what? 1 by root 2 pi minus infinity to infinity. Here your function is this, f of omega exponential minus I omega x. Okay, so here it is k, so we can just replace omega with k everywhere because, but omega and k are related, so don't get confused.
Actually, they have gone from x space to k space. I think that's why they have written x and k.
Yes, yes, yes. You can just write anything like k. Everywhere you can write k. It's fine. Wait. Yeah, so here that is the thing. The X space with K space. So K space is nothing but every,
Reciprocal space, I
yeah, it's
guess.
frequency space only. Okay.
Yes, actually, whenever we do some XRD or anything, we grow from real space to the reciprocal space that we define it as a K space,
Yes, yes,
the
yes,
Fourier transform. So,
yes, yes. Yeah. So we can just write this f of k e to the power minus I k x d of k. So Fourier transform of this f we can write in this form, and suppose this is 4. Now if you just replace this, if you just replace in this question your x with minus x, so you will get, so I'll do another page. So if you just replace x with minus x in this equation 4, so you'll get something as 1 upon root 2 pi f of k exponential I kx dk. Just replace x with minus x. Okay. And this is what? This is nothing but the inverse of f of k. Is it clear? This is nothing but the inverse of f of k. And
yes.
from here, we know that inverse of f of k is f of x. So we have just replaced, if we just replace in this question, in this with x with minus x, so we'll get this. So this is nothing but f of minus x. So let me make it a little more clear here. Some confusion. So your f of x is nothing but f inverse of fk, which is 1 by root 2 pi minus infinity to infinity f of k exponential I kx dk. This is say one equation A. And you've already found that f square of f of x, f square of f of x is what? Is also 1 by root 2 pi minus infinity to infinity. This equation writing f of k e to the power minus I kx dk. Now in this B equation, if we just replace x with minus x, then we will get equation A. Okay, and which will be nothing but f of, or in equation A, if you just replace x with minus x, you will get equation B. So you just, in this way, this f of square is nothing but f of minus x. You just replace x with minus x, so you will get equation B. So in this way, option C is correct. Is this clear? Okay, so just you have to do, what you have to do is that you have to just find this Fourier transform, like, is this clear, or shall I repeat it?
I actually got it mathematically, but I was
Sir,
trying.
previous slide.
Okay, previous slide. Yeah.
Sir, you have taken inverse form now in third step.
Yeah,
After
this,
that,
yeah, after that, actually what you do is that, after that I have just trying to do this. Since Fourier transform of any function can be written in this form, so Fourier transform of f of k I've written, just replace fx with f of k. Okay.
okay, sir, clear.
Mhm.
Sir, actually, just I'm asking this as a question, although I have got it mathematically, that when we are doing Fourier transform twice of a function, it is the same function is coming back with inverse space parity of something like that is f of x is becoming f of minus x. Is there any physical meaning? Is there any physics behind it or any physical interpretation of it? That.
Yeah,
Why is this?
like when we do like research, do the, like we do not mostly we do not deal with like f square. We just what we do is we have some f of x, then we just we have some time series and we just do the Fourier transform and then
Yes.
plot the power spectrum as I showed in the first slide, and then we show the frequency. But f square, like I have not in my like physically I have not understood that what is the like physical significance of taking the Fourier transform of the Fourier transform. So I think it's just a mathematical approach, just for fun of solving. I think they have given this kind.
Okay. Okay.
Mhm. But always you can give some like you can ask someone else, or maybe if you can just do your own research, like maybe some good book you can refer and find that what is. But till now, I have not seen anywhere the application of f square. I have not seen. Okay, so these are some questions on the Fourier transform which we solved. So it's basically based on properties, and if you have some basic some basic, you just need to remember some basic this formula and then some property, shifting property, and those properties, and then you can just solve the question. Now, for Laplace transform, I think Laplace transform should be taught before Fourier transform because it is a more generalized. It is a more generalized concept. So Laplace transform is studied to. It is used to solve complex linear differential equation. Okay, so suppose you have any function f of t, then you take the Laplace transform of that function. So in the Fourier transform, you converted this function from time domain to frequency domain. Here you convert the function from time domain to some Laplace domain. So that Laplace domain is nothing but S. So it is represented as this, and mathematically you must be knowing that Fourier Laplace transform of any function f of t is nothing but f of t e exponential minus st dt, where your s is your Laplace operator, and it has both real as well as imaginary part. Okay, so this is one important concept, that this Laplace transform has both real and imaginary part, and for case when your real part is 0, then S becomes just j omega, and your Laplace transform converts to what? It converts to Fourier transform. So Fourier transform is just a special case of Laplace transform. So sometimes they ask some questions in like, so Laplace and Fourier transform connected to each other. So yeah, this is how we represent the Laplace transform of any function f of t. So these I've taken from internet. So some of the properties which you need to remember for your GATE exam, you can easily solve it also, but you do not have much time. So for some standard functions like exponential, sine, cos, similarly cos hyperbolic, sine hyperbolic. So you need to remember the Laplace transform of these functions so that you can easily solve the question in less time. Okay, so for example, this is the question which came in GATE 2013, question number 26. So this question they have asked which of the following pairs of the given function and its Laplace transform is not correct. So the first function is just, we can just easily say that it is nothing but del of t exponential minus st dt. So it is nothing but, if you just integrate it, you will get exponential minus 0 t, it is 1. So first is correct. Second option, exponential minus st dt. So when you integrate it, then you will get something like, you'll get what? You'll get okay, 1 minus e to the minus infinity upon s. So second option is also correct. When you solve for the third option, so sine of kt exponential minus sine dt. So you just convert it into the exponential form, and then you just solve it. So easy to solve, not difficult. Exponential minus t s minus I k minus exponential minus t s plus I k dt. So just multiply this with this. And now you can just easily integrate this. When you will just integrate it, you will get something like this. I have one two step I am just skipping because you can easily do. You will get something like 1 minus sik minus 1 upon s plus iota k. And when you solve this, you will get 1 upon 2i s square plus k square and s plus ik minus s plus ik. So 2i cancel. So you will get k upon s square plus k square. So Laplace transform of sinusoidal function is k upon s square plus k square. But in the question they given s upon. So this is wrong. Similarly, when you find the Laplace transform of this, you will get this. So option A, B, and D will be correct. And option C is not correct. So you can just find that option C is correct. And if you remember the formula, then you can easily, you don't have to solve all these things. You can just easily know that exponential of sine of kt is some constant upon s square plus b square. So just no need to solve. You just easily find out that okay, this option is found. Clear, right? Hello.
Clear.
Okay. Now this again another function they have given that if f is the Laplace transform of some function f of t, then Laplace transform of the function which is scaled by. Okay, so here what they've done is that they have multiplied t with a, so it's called scaling. So they've scaled t with some constant a, with some constant a. So if Laplace transform of f of t is 0 to infinity f of t exponential minus st dt, then Laplace transform of the function scaled is what? So you just replace simply now at you just assume as some u, so dt will be du by a. So 0 to infinity f of u exponential minus s, t is nothing but u by a, and then here du by a will come. So it will come 1 by a exponential minus u s by a will come as a constant. Oh no, you can just no constant. You just s by a u du. Now just compare 2 with 1. If you just replace in 1 s with s by a, so you'll get. So it is nothing but 1 by a Fourier transform s by a, because we know that this is f of s. So if you just replace s with s by a, so it will become f of s by a. So in this way, option B is correct option for this question. Clear, right?
Yes.
So these are some straightforward questions. Now again this is another question which again uses some property. So they have given some function f of t is sine of pi t, and the Fourier transform this function is pi upon s square plus pi square. And what is the Fourier transform of the function which is multiplied with t? So there is some common property that the Laplace transform of t to the power n f of t, if we have this kind of function where we know what is the Laplace transform f of t, and we need to find the Laplace transform of t to the power n f of t, then it is, we can remember it by a simple formula f of s. where f of s is nothing but the Laplace transform f of t. So in our case, our function is sine of pi t, and your power of t is 1, so your n is 1. So Laplace transform of t sine of pi t is nothing but minus 1 d upon ds, because n is 1, pi upon s square plus pi s square. So when you just solve this or differentiate this, sorry, so you'll get s square plus pi square, just using dividend rule, minus pi 2s. Sorry, pi is already taken out, so minus 2s. So it will become 2 pi s upon s square plus pi square whole square. So just using simple this formula, you can just find it has come out to be 2 pi s upon s square plus pi square whole square. So option C. So just this is a simple problem. Again, you just find out this is Laplace transform. So see, they don't ask very tough questions. They just a very simple question most of the time. One or two times they ask some complicated question, but most of the time, if you're able to remember some basic properties, then you can easily solve gate question very easily. Okay, now suppose in this question they have asked you the Laplace inverse of s plus 1 upon x square minus 4. So you can just write this as s upon s square minus 4 plus Laplace inverse 1 upon x s square minus 4. You can easily write this, right? Now, if you remember what is the Laplace transform cos of ht, so I've solved it somewhere. So it is nothing but, suppose cos of hat. So Laplace transform of cos hyperbolic of some at is nothing but s upon s square minus a square, and c is a upon s square minus a square. Okay, so you just use these two properties in equation 1. So your Laplace inverse of s upon x square minus s square minus 2 square is nothing but, using this, we can write this as cos hyperbolic 2 of t. So your first term is nothing but cos hyperbolic 2 of t, and your second term, when you just multiply and divide by 2. So like using this equation, you can just write it as 1 by 2 times Laplace inverse of 2 upon s square minus 4 is nothing but sine hyperbolic 2t. So cos hyperbolic 2t plus of half of sine hyperbolic 2t. So yeah, D option is the correct. Cos hyperbolic 2t plus half of sine hyperbolic 2t. So this is the correct option for this question. They've just given C this to confuse people. Normal cos and sine functions. So, but the correct answer is this. So here also, see, you just remember simple, this kind of, this table is very important. You just remember, and some more functions also, you just remember this kind of Laplace transform. Then you will just solve this very easily without wasting time. Now, okay, the last question for day, it came in 2021. So this is a question which we are trying to teach when in the starting of Laplace transform. So they've given that the Laplace transform of some function f of t is defined as 0 to infinity exponential minus st f of t dt. And this Fourier transform of the same function is same. So the Fourier transform of the same function is given by f omega 0 to infinity f of t exponential minus. We know this. Now there are four options. So they have asked which one or two. So it's whenever in the question they're given statement bracket S, that means that there can be more than one option correct. So they've asked which one of the options are correct. So first option is that both Laplace and Fourier transform can be made connected. So as I discussed in the starting, that if we just replace in the in equation 1, replace S with I omega, because we know S is a Laplace operator which has both real and the imaginary part, so it is complex in nature. So if in the case when real part is 0, so you're left with only with imaginary part, and if you replace equation 1 S with this imaginary part, so what you'll get is nothing but f, f of t exponential minus j, or which is nothing but equation 2. So you put this in equation 1, you'll get equation 2. So option A, that Laplace and Fourier transform can be made connected, it is true. It is true. With this Laplace operator, we have find that this both Laplace and Fourier transform are connected. Laplace, yeah. Hello?
One question. Yes,
Hmm.
one question. Actually, in case of Fourier series, the limit is from minus infinity to infinity for any function, whether we don't know it is odd or even. So whenever we are transforming this Laplace into Fourier, the limit is becoming 0 to infinity. So can we say that only for even functions the Fourier transform will exist in this case, I guess? Because when you are
Hmm.
putting s equals I omega, the limit is from 0 to infinity, not from minus infinity to infinity.
That depends upon the question. Like generally, Fourier transform, your limit is from minus infinity to infinity. But suppose if some question is, and if some signal is there which is 0 for less than 0, then in that case you will just replace the limit with 0, right? Minus infinity.
Yes. Or
So
if it is an even, if the total
yeah,
integral becomes even, then we can also
then
do that.
then also you can do that. Then also you can do it. Just twice times 0 to infinity. Okay. Yeah. So that's right. Okay. So is the doubt clear? That's what you were asking.
Yeah, I was just asking that is there any way why is there any specific reason why this limit 0 to infinity we are calling it Fourier transform, but
No, no, no. Acha, acha, yeah. So
hmm,
actually, in Fourier transform, you do not only deal with signal in time domain. Like you can have signal different. Like you can have some trigonometric signal which is not related to time. But in Laplace transform, it is more application based. The application of Laplace transform you'll find a lot in electronics when you sign these circuits. As far as I remember, then you have some Laplace transform, and Laplace transform is exclusively for the time domain signal, and you do not encounter with negative times. Time cannot be negative, right?
okay, got it. Thank you.
The time is always positive. Yeah. So so that's why in Laplace transform we do not have negative. So we have only positive.
Okay, got it.
Okay, so in this way, we've seen that option A is correct, that both Laplace and Fourier are connected. The variable S is always real. This is incorrect because we know that this can be has both real and imaginary part. So option A is correct. Option B is not correct. Option C, the variable S can be complex. Yes, it is true. And option D, that they are not connected. So wrong. So option A and option C are correct. So you have to choose both these options for this question. So yeah, so in this way, option A and C is correct for this question. Okay, so these are the questions which I found in the last 20-year GATE papers. One or two questions I might have left, which you can solve. And so that broadly covers the mathematical physics part. We have covered almost everything like Fourier Laplace, complex, linear vector space, differential equation, those kind of things. Yeah, so no doubt related to this. Any doubt related to this class?
Just one doubt, although it is not of mathematical part. Suppose
Mm.
in case of Fourier transform, we are connecting two conjugate variables, right? Either we are connecting, no, actually not. I mean, we are connecting x with k, which is a momentum. K is
Mm.
related with some momentum. So
Okay.
in case of Laplace transform, we
Mm.
are only transferring it to something signal in time domain to something in that S domain, right?
Yeah, S domain.
We
Yes, it is a complex domain. We call it some complex domain.
Okay. So it is basically some kind of complex domain we are where we are transferring the signal for some mathematical formulation.
Yes, right.
Okay.
Uh, yeah, good. Thanks. So yeah, so how is the preparation like going on? When is exam? 11.
Yes, the exam is in 11th.
So right now you must be doing practicing questions only. Syllabus must be covered. No?
Yes.
Yeah. So you can just solve questions easily. Like you just take out 4-5 hours at daily and then solve questions. That's the only thing like to do before exam. I would advise not to go into some topics, fresh topics. Not very advisable. It's very lengthy. Otherwise, some short topics you can study. Okay, so then I can just wish you all the best for your exam. I wish you just clear it.
Thank you, sir.
Thank
Yeah,
you, sir.
all the best. Okay, then I will just. And also the questions they've uploaded on the NPTEL portal. These questions, the video solution of the questions, gate questions. You can on YouTube when you just type NPTEL gate preparation, then you'll get those videos. So those videos you can see some questions for all topics, like not mathematical, but other topics also, quantum, classical. Okay. Okay. So thank you.